Are Santorini and Campi Flegrei Seismic Swarm a warning about something bigger? What if the Earth wasn't as still as it feels beneath your feet? What if instead it constantly whispered signs of unrest? Tremors here, quakes there, hints of something happening deep below the surface. That's the reality of seismic swarms, nature's mysterious chain of earthquakes that often leave us wondering, are they harmless? Or are they the Earth's way of warning us about something bigger? Seismic swarms are one of the Earth's most fascinating and misunderstood phenomena. Unlike the dramatic, headline-grabbing earthquakes that strike suddenly and fade, seismic swarms are quieter, more persistent, but no less significant. They consist of a series of smaller earthquakes clustered in one area over days, weeks, or even months. Some are so small you wouldn't even feel them without sensitive instruments, while others can shake buildings and rattle nerves. What sets them apart from typical earthquakes is the lack of a clear main shock, a single dominant quake followed by aftershocks. Instead, seismic swarms are more like a constant conversation between the Earth's tectonic plates rather than a single loud shout. But why do these swarms matter? On the surface, they might seem like geological noise, minor tremors with no real consequences. Yet their true importance lies in what they can reveal about the forces at work beneath our feet. Seismic swarms are often tied to the movement of tectonic plates, magma shifting under volcanic systems, or stress building up in the Earth's crust. In some cases, they might act as a release valve, relieving pressure without much damage. In other cases, they could be nature's way of hinting at something more serious, a larger earthquake or even a volcanic eruption. Think of them as the Earth's version of a warning light on your car dashboard. They don't guarantee disaster, but they demand attention. Now let's break it down. Earthquakes generally follow a predictable sequence known as main shock, aftershock. A single large quake occurs, the main shock, and is followed by smaller aftershocks as the crust adjusts to the sudden release of energy. Seismic swarms, on the other hand, don't follow this pattern. There's no main shock, no big event to mark the start of the activity. Instead, the quakes in a swarm are roughly similar in size and occur repeatedly over a short period of time. It's like comparing a single dramatic explosion to an ongoing series of firecrackers. Both are loud, but the firecrackers keep your attention for longer. So what causes these strange clusters of quakes? The answer depends on where they occur. In tectonic regions, areas where the Earth's plates collide, pull apart, or slide past each other, seismic swarms might happen when stress in the crust is gradually released over time, rather than all at once in a large quake. This can happen along fault lines or even in areas where the crust is bending or stretching. In volcanic regions, however, swarms usually mean something entirely different. They can signal that magma is moving underground, pressurizing rocks as it forces its way upward. In this case, seismic swarms are often a precursor to volcanic eruptions, giving scientists valuable clues about what's happening beneath the surface. Europe is no stranger to seismic swarms, thanks to its complex geology. The continent sits at the meeting point of several tectonic plates, including the African, Eurasian, and smaller microplates. This makes Europe a hotspot for seismic activity, particularly in areas like the Mediterranean, where the African plate is subducting beneath the Eurasian plate. Volcanic regions like Iceland, Italy, and even Greece are especially prone to swarms because of the movement of magma beneath the surface. Take Iceland, for example. This island nation sits on the mid-Atlantic ridge, where two tectonic plates are pulling apart. Seismic swarms here often precede volcanic eruptions, as magma rises to fill the gaps left by the spreading plates. Similarly, in the Azores, a volcanic archipelago off the coast of Portugal, seismic swarms are frequent due to both tectonic and volcanic processes. But some of the most famous seismic swarms in Europe occur in the Mediterranean, where the continent's most active tectonic and volcanic systems collide. Currently, two seismic swarms are drawing attention in Europe, one in Santorini, Greece, and the other in Campi Flegrei, Italy. Both regions are geologically unique, sitting at the intersection of tectonic and volcanic processes. In Santorini, the swarm is likely influenced by the Hellenic subduction zone, a tectonic plate boundary where the African plate is sinking beneath the Eurasian plate. Meanwhile, Campi Flegrei near Naples is a massive volcanic caldera that has been simmering with unrest for decades. These swarms are not only fascinating from a scientific perspective, but also critical for the safety of the millions of people who live in these regions. Seismic swarms, in essence, are a reminder of the Earth's restless nature. They challenge us to think critically about how we understand and interact with the planet we call home. Are they simply the Earth's way of relieving stress, or are they the precursors to something far more significant? When it comes to seismic swarms in Europe, two locations are currently stealing the spotlight: Santorini, Greece, and Campi Flegrei, Italy. These regions are not just geological curiosities, they're hotspots of tectonic and volcanic activity that have the potential to shape the lives of millions who live nearby. Each location tells a unique story about the forces that drive seismic swarms, and together they offer insight into the incredible complexity of our planet. So what exactly is going on in these two regions, and what makes them so fascinating and potentially dangerous? Santorini is widely known as one of the most beautiful islands in the world. Its iconic whitewashed buildings perched on cliffs above the caldera are the stuff of postcards. But this picturesque paradise is also a geologically restless zone, sitting on the Hellenic subduction zone where the African plate is diving beneath the Eurasian plate. This tectonic activity has shaped the island's dramatic landscape and created one of the most famous volcanic systems in Europe. Since early 2025, a swarm of earthquakes has been occurring in the region, with activity centered between Santorini and the nearby island of Amargos. These quakes are relatively small in magnitude, most ranging between 3.0 and 5.1, but their frequency is what has caught the attention of scientists. Dozens of tremors have been recorded in a single day, creating an almost constant state of seismic activity. GPS data has also detected minor ground deformation, suggesting that the Earth's crust in the area is under significant stress. Historically, Santorini has seen seismic swarms before, but these events are always closely monitored because of the island's volcanic history. The massive Minoan eruption, which occurred around 3,600 years ago, was one of the largest volcanic events in human history. It wiped out settlements, triggered tsunamis, and even influenced the collapse of ancient civilizations. While the current seismic swarm doesn't necessarily mean another eruption is imminent, the possibility of magma movement beneath the surface cannot be ruled out. For the residents of Santorini and nearby islands, the swarm is both a reminder of the island's volatile nature and a reason to stay vigilant. The big question for Santorini is whether the swarm is purely tectonic, caused by stress along faults, or whether it's signaling deeper volcanic activity. Scientists are analyzing seismic data, gas emissions, and ground deformation to understand what's happening. For now, the swarm remains a fascinating but uncertain phenomenon, one that holds the potential for both scientific breakthroughs and significant risks. While Santorini's seismic swarm is largely occurring offshore, the situation at Campi Flegrei in Italy hits much closer to home, literally. Campi Flegrei is a massive caldera located just west of Naples, one of Europe's most densely populated cities. Unlike Santorini, which is a single volcanic island, Campi Flegrei is an expansive volcanic system that has been simmering with unrest for decades. Its name, which translates to burning fields, is a fitting description of the region's volatile nature. Since early 2025, Campi Flegrei has been experiencing a swarm of shallow earthquakes, with magnitudes mostly between 2.0 and 4.0. While these quakes are smaller than those in Santorini, their proximity to the surface and to populated areas makes them far more noticeable and concerning. Residents in Naples and surrounding towns have reported feeling the tremors, and many are growing increasingly anxious about what these swarms might signify. Campi Flegrei's history makes the current swarm especially noteworthy. The caldera has erupted multiple times in the past, with the most recent eruption, Monte Nuovo, occurring in 1538. While that eruption was relatively small, earlier events were catastrophic, releasing massive amounts of ash and lava. Some scientists classify Campi Flegrei as a potential supervolcano, capable of producing eruptions that could have global consequences. The current seismic activity, combined with years of ground deformation and increased gas emissions, suggests that the system is under pressure. But whether this pressure will result in an eruption or simply subside is still unknown. Here's something to think about. If you lived near a geologically active zone like Santorini or Campi Flegrei, how would you handle the uncertainty of living with constant seismic activity? Would you trust the monitoring systems and scientists, or would the unpredictability make it too stressful? Let us know your thoughts in the comments. While Santorini and Campi Flegrei are both experiencing seismic swarms, the processes driving each are quite different. In Santorini, the activity may be purely tectonic, related to plate movement in the Hellenic subduction zone. However, the island's volcanic history means that magma movement is always a possibility. In Campi Flegrei, on the other hand, the swarm is clearly linked to volcanic unrest. The shallow depth of the quakes, combined with ongoing ground deformation and gas emissions, suggests that magma and gases are accumulating beneath the surface. Despite these differences, both regions highlight the challenges of living in geologically active areas. For scientists, these swarms present an opportunity to study the Earth's inner workings in real time. For residents, however, they are a source of anxiety and a reminder of the unpredictable power of nature. Evidently, the seismic swarms in Santorini and Campi Flegrei are more than just isolated geological events. They are part of the Earth's ongoing story, a dynamic and ever-changing system that shapes the landscapes we call home. The effects of seismic swarms ripple out in ways that aren't immediately obvious. While individual tremors in a swarm might feel minor, their collective impact can be significant. First, there's the environmental risk. In volcanic regions like Campi Flegrei, swarms are often associated with magma shifting underground. This movement can destabilize the ground above, causing cracks, land deformation, or even landslides in steep areas like Santorini. Such changes in the landscape can have immediate consequences for local ecosystems, disrupting water supplies, vegetation, and wildlife habitats. In extreme cases, swarms can escalate into full-scale volcanic eruptions, releasing ash, lava, and gases that further alter the environment. For Santorini, this raises concerns about its fragile islands and the surrounding Aegean Sea, while for Campi Flegrei, the potential environmental stakes are even higher due to its densely populated surroundings. Then there's the human element. Living through a seismic swarm can be a nerve-wracking experience, as the ground beneath you keeps shaking with little warning. The psychological toll is significant, especially when the cause and outcome of the swarm remain uncertain. For the residents of Naples, the constant tremors from Campi Flegrei bring back memories of past eruptions and fears of what might come next. Similarly, in Santorini, locals and tourists alike are left wondering whether the region's volcanic past might repeat itself. Anxiety and stress run high, especially when every shake feels like it could be the precursor to something far worse. On top of this, seismic swarms can bring serious economic consequences. Santorini, for example, is one of Greece's top tourist destinations, drawing millions of visitors each year who come for its iconic views and serene atmosphere. A prolonged swarm could deter tourism, leading to significant losses for local businesses that depend on visitors. In Campi Flegrei, the stakes are even higher given the proximity to Naples. A major eruption or prolonged seismic activity could disrupt transportation, damage infrastructure, and upend industries that drive the local economy. The financial costs of rebuilding or mitigating damage can be astronomical, adding another layer of stress for affected communities. Despite their unpredictable nature, seismic swarms are not entirely unknowable. Scientists have developed sophisticated tools and methods to monitor and study these events, giving us better insight into what's happening beneath our feet. One of the primary tools used in studying swarms is seismic data. Networks of seismometers are installed in geologically active regions to record tremors, even those too small to be felt by humans. These instruments allow scientists to track the frequency, location, and depth of earthquakes in real time. For example, in Campi Flegrei, the shallow nature of the current swarm's quakes suggests that magma and gases are moving closer to the surface. Not a guarantee of an eruption, but a critical clue nonetheless. Ground deformation is another vital indicator. Using GPS stations and satellite-based techniques like INSAR, interferometric synthetic aperture radar, scientists can detect even the slightest shifts in the Earth's surface. In both Santorini and Campi Flegrei, ground deformation has been observed, pointing to the intense pressure being exerted underground. These subtle changes in the landscape often precede eruptions, making them a crucial part of volcano monitoring. Gas emissions also provide key insights. In volcanic regions, the release of gases like carbon dioxide and sulfur dioxide can signal magma movement. At Campi Flegrei, increased gas emissions have been detected in recent years, raising concerns about the caldera's activity. By closely monitoring these emissions, scientists can better understand what's happening underground and provide early warnings if necessary. While no method can predict seismic or volcanic events with certainty, advances in technology are helping scientists improve their models. Machine learning and artificial intelligence, for instance, are being used to analyze large data sets from seismic and geological monitoring systems. These tools allow researchers to identify patterns that might suggest when and where future activity could occur, bringing us closer to understanding the behavior of seismic swarms. As much as science helps us understand seismic swarms, there's no escaping their inherent unpredictability. This makes preparedness essential for communities living in geologically active regions. Education is the first step. People living near areas like Santorini and Campi Flegrei need to know the risks they face and how to respond in the event of an emergency. Public information campaigns, school programs, and community workshops can help raise awareness and ensure that residents understand basic safety protocols. Informed communities are more resilient, capable of responding quickly and effectively when disaster strikes. Emergency planning is another critical component. Governments and local authorities must have comprehensive disaster response plans in place, including clear evacuation routes, effective communication systems, and strategies for distributing resources in the event of a crisis. In Campi Flegrei, officials have already established an alert system that warns residents of escalating volcanic activity, helping to reduce panic and ensure a coordinated response. On an individual level, preparedness means having an emergency kit with essentials like water, food, and medical supplies, and knowing the safest places to take shelter. It also means staying informed by following updates from trusted sources, such as geological institutes and emergency management agencies. At a broader level, preparedness involves strengthening infrastructure to withstand seismic activity. Buildings in active zones should adhere to strict construction standards, and older structures should be retrofitted to make them more resistant to earthquakes. In places like Santorini, preserving historic architecture while ensuring safety poses a unique challenge, but it's one that must be addressed. Seismic swarms remind us that Earth is a living, breathing system, constantly in motion beneath our feet. They challenge us to confront the risks of living on such a dynamic planet, while also offering opportunities to learn and adapt. By studying these swarms, scientists gain invaluable insights into the processes driving tectonic and volcanic activity. These lessons not only help us better understand our planet, but also improve our ability to protect the people and communities affected by these events. Santorini and Campi Flegrei are stark examples of the delicate balance between humanity and nature. They show us both the power of geological forces and the resilience of the people who live in their shadows. As we continue to monitor these swarms, one thing is certain: the Earth's story is far from over, and it's up to us to listen, learn, and prepare for whatever comes next. If you found this exploration into seismic swarms fascinating, don't forget to hit the like button and subscribe to our channel for more insights into the mysteries of our ever-changing planet. And as always, stay insanely curious.